Hi everyone, so I'm going to be covering problem 29 from section 2.4 of the textbook by Trench. We can go take a look at that real quick. Okay, so it says we're going to have to solve the homogeneous equation implicitly. So there isn't an explicit solution to this differential equation, and this wasn't one that was assigned under the lecture videos, so I thought I'd give it a try and see what I can find. So the problem is x dy dx minus y times the difference of two logarithms equals to x. So by the ubiquitous property of logarithms that we've been seeing since high school, we have log a minus log b equals to the quotient of whatever's inside. So we have x dy dx minus y times the log of y over x equals to x. And then I divide by x, assuming it's not 0. So we have dy dx minus y over x times log y over x equals to 1, since x over x is just 1. And now, since I have a y over x, and a y over x, I'm just going to substitute u equals to y over x, which means ux equals to y, by moving that x up. And by the product rule of differentiation, we have dy dx equals to u dx dx, which is just 1, plus x du dx equals to u plus x du dx. Or we could just refer to the properties of differentials, which give us a product rule. There it is. So we have dfg equals to fg prime, which just resorts to the product rule there. Then we just divide everything by dx, since that's our independent variable. Now we have u plus x du dx minus u times log of u equals to 1, and the u's cancel, so we substituted all of this for dy dx in this equation, and the y over x just became a u, and the y over x just became a u, so the two u's cancel, so we're just left with x log u du dx equals to 1. And this equation is separable, so we're just integrating a logarithm, and we're integrating 1 over x, which turns out to be a logarithm. This integral on the left should be solvable by integration by parts, but to check, to make sure I haven't messed up anything, we can check with our handy-dandy TI-89. So you can see here I've integrated the natural log of x with respect to x, and we just get x ln of x minus x. And putting that in, we have u log of x minus x equals log x plus some constant of integration. Then I pull the u out, so we have u log u minus 1 equals log x plus c naught. And now we can substitute back in for our u, which we said was y over x, assuming, again, x is not equal to 0. So we have y over x log y over x minus 1 equals to log x plus c naught. And we can separate these logs again if we would like, and I've also moved the x up to the right hand side because it's all x's over there. So, and it turns out you can't solve the left hand side, at least I can't see how you'd solve for it, for just y, so we can't just get the y's alone on the left hand side. And thanks for watching.